Hi, I'm Chris.
I'm Natasha.
And I'm Dave.
Coming up on the Automation Village.
Industry news.
Automation tips and tricks.
Our security roundtable.
An industrial case study.
A live rocket test.
And plenty of chances for you to get involved.
And we'll see you in the Automation Village.
Hey everybody, welcome to the Automation Village, a show for people who love all things automation.
This is Chris Little, I'm Dave Spencer, and joining us is social media, Natasha Lutz, and our producer, Peter Diffley.
And over the next hour, we're going to bring you case studies, interviews, and also some prizes. We're going to give away a bunch of prizes.
That's right, Chris. I should have said that off the top.
That's why it's live.
Yeah, so we are joining you live for the next hour.
From this virtual studio, by the way, our brand new virtual studio that still has that virtual smell to it.
That's right. And from my perspective, that virtual smell is very much the smell of hot electronics.
And for me, the smell of hot electronics brings up an image of a small rover on Mars.
Yes, I will agree with you there. And speaking of a small rover on Mars, that's what we always talk about at the top of the show.
It's time for drone talk. So if you've been tuning in every month, you'll know that we talk about the doings and drivings of each of the rovers that are on Mars. So this week we're going to talk about the latest in
Ingenuity.
Ingenuity, which is the helicopter that flew out of
Perseverance.
You get a candy bar.
Right,
so what's new about this one? This is not the first time this helicopter has flown, right?
No, this is the 12th flight, actually. And this helicopter was only really scheduled to do a small handful of flights. Right. So they've been really kind of pushing it. Now, the science portion of the mission is done, and they're allowed to have a little more fun with the helicopter.
Right.
Now, previously, everything didn't go perfect. So in this mission, what they really pushed was the navigation capability, because there's no GPS or anything on Mars. So they're using two different navigation systems. One's inertial, and the other's using more of a photogrammetry, where they're looking at the surface and doing it almost like your mouse works, where they sort of look at the changes and try to track where the rover's going. But they're doing everything in 6 degrees of freedom, so it's more complex than it sounds.
Right, that's amazing, considering that there's such a time delay. The drone basically has to do it all itself, and then tell us about what happened.
That's right. Yeah. So the drone basically gets a schedule of the flight, and then is required to land on its own. And then charge up to prepare for the next one.
That deserves a prize. And speaking of prizes, we're going to tell you one of the ways in which you could win a fairly significant prize later on in the show. So basically, we are going to bring up at some point, we're going to surprise you with a code phrase or a code word. And we're not going to be subtle. When it comes up, we are definitely going to shout that code phrase at the screen, and then you're going to send it back to us.
Yeah, that's right. So basically, queue up your emails. You're going to have natasha.lutz@trihedral.com in that to address, and that secret phrase will be what you write in the subject line. And I'm trying not to say it now because I am looking at it.
Yeah, I know. So 2 lucky people who send in the correct response are going to win each a $100 gift card from a popular online shopping utility that has a connection to the space industry now.
That's right. Which actually is turning out to be all of them, but nonetheless, we digress.
That's true.
It's just billionaires in space.
So next, we're going to bring you some tips and tricks for people who are into SCADA configuration from somebody who does a lot of SCADA configuration. That's our regular contributor, Sam Black from EMC.
Hi, my name is Sam Black. I'm a developer at Electric Machine Controls. We are a system integrator over in Trussville, Alabama. And I've been asked to share a couple tips and tricks that I've picked up in the world of VTScada throughout the years. So let's just jump right into it. One of the things I'd like to talk about is how to deploy widgets in a way that scales well and is easy to adapt. The first and kind of most basic way you can draw anything on a page is bespoke. And what I mean by that is each individual item is individual. These are text boxes, these are image widgets, things like that. It's easy to adapt because you are just making new objects each time, but it's very difficult to deploy and maintain. If you've got 100 of these pumps and you realize down the line that you needed to make a small change to one of them, you are in trouble. You're going to be making 100 of those changes. So here, for example, we've got a second pump. I had to make a whole nother instance of that, and on each one, right click, go to properties, do all this kind of jazz. So one of the first things they teach you in the VTScada class is how to make a tag widget. And these are really great. For most of what you need in a widget, they're all you need. So a tag widget is basically you take all of this, right click, group, new widget, and you tell it, base yourself on the context of a pump. So everything that is a child of that tag is encompassed and taken care of. And that's really great. If you've got a second pump, all I need to do is link it to a pump. There's no individually going in and changing things. So it's awesome if you've got a bunch of very identical tag structures. So easy to maintain, easy to deploy, difficult to adapt. If you had a pump that was somehow different, like it had a tag that was, instead of running, it was called pump status or something like that, this widget just doesn't work. It will have an error message on it. So a way to get around that is what's called a group widget. And this is actually, historically, was invented before the tag widget, from what I understand. And you would make one of those by selecting your bespoke item, right-click, group, and just going to group, or new widget, and new widget. And these guys are a little different. If you right-click on them, you can see rather than telling them, just the pump, you have to spoon feed it each individual component that will be displayed inside of that widget. So you've got running, speed, and then the pump itself for naming and things like that. So it's easy to maintain. If you make a change here, it's going to go everywhere. It's easy to adapt. You obviously point whatever tag you need at the run signal, whatever tag you need at the speed signal. It's pretty flexible. It's annoying if you're going to be doing 100 of these pumps. So if you've got a new pump you need to make each individual time, you've got to go in here, right-click, pick out the running tag, pick out the pump tag, pick out the speed tag. And the odds that you're going to forget one of those are pretty high. So you end up having a lot of service calls later in the game as you're trying to fix these things. There's another kind we can use that I would like to propose called a nested tag and group widget. And what this is, when you right-click on it, it looks just like a tag widget, like we did back here. See, we're just pointing it at a pump. But if we dive into this, we can see that this widget actually contains another widget. So inside of here, we've got another widget that's just a tag widget, and we've called it generic pump. So we've got running, pump context, and speed. So this looks like you're sort of just making more work for yourself. You might ask yourself why. Let's take a real-world example here. So we've got a plant that we're doing that's got hundreds of pumps. So we'll right-click on new pump here, and we can see, great, we've developed this widget. It works awesome. We've done this nested group and tag widget, but we've got an existing pump too. And let's take a look at its tag structure. So on new pump, we've got running and speed. On existing pump, we've got P1 running and P1 speed. And this is actually really common when you're adapting existing SCADA systems. Some other packages, Wonderware, iFix, things like that, when they develop them, they will give each tag its own unique name. So if you try to make a widget that accounts for all this all the time, you're going to be making 100 different widgets. So let's go in here. We've got our widget here, and we're going to copy paste it. And we want to make this thing work on this other type of pump. So what we're going to do is ungroup it. And now we still have the same widget, but when we right-click on it, we can go in and make custom choices. So rather than new pump 1, if we have this one-off pump that's new pump 2, we can go select specific tags. And when we do this, this is still the same widget as we had before. So if we make a change here, sorry, let me wrap this up. Let's say that the customer decides they want something in this. So let's say that they wanted a triangle in the middle of the pump. Now, that triangle appears in all of these. We don't have to go back and make changes, even though this is technically a different widget. This is a tag widget, and this is a group widget. So the way that you do this, I'm going to undo this change we just made. Delete our triangle. So the way that we do this, let's say that we have our group widget that we talked about earlier. So this is the one where you have to individually hand feed each individual one. And let's say that you have a type of pump that you know you're going to be doing a lot of. So we've got our pump here. Let's get Ryan Reynolds out of here. So we're just going to throw in anything. It really doesn't matter, just some text. And we're going to select our group widget here, right click, group, new widget. And we're going to make a new tag widget for our new pump. And there we go. Now you've still got this text here to delete. The reason we throw that in is because if you don't have something new and exciting to include in that widget, it won't let you make them. So now we have this special widget that when we're making 100 of these pumps, all we have to do is point it at a pump. But if we need to go and make something custom, we can ungroup it. And we're back to our tag widget. So let's say that you had a lot of these existing pumps. Well, here you wouldn't really be able to do it. They have individual unique tag names. So there's a way to do that too, but that's for another time, I think. But yeah, so whenever you have a pump that follows a standard protocol, you can use this, this sort of tag widget here. And when you have something that is a one-off, you ungroup it and pick individual tags.
All right, so that was great. We want to thank Sam for that. And next up, we're going to take things over to Pam Moss with Hawk. Hey, Pam.
Hey, Pam.
Hey there, Chris and Dave. How are you guys doing in your virtual world?
It's great. The floor is really spongy.
Yeah, I've been mining Bitcoin in the background.
How's everything with you?
Doing great here in beautiful Charlotte, North Carolina for a couple days. Then headed back to the coast. So yeah, lots going on. Pretty exciting. So thank you.
What's up this week on the data wave?
Yeah, so we're going to look today at the data wave at a great topic called operational availability. But I would like that picture of Ryan Reynolds to come back if we could do that.
It's true. Do you have any pictures of Ryan Reynolds that you'll be sharing?
Hey, I've got Pete, Ian, and Lee, so I'm good. I'm good.
Oh, that's even better.
Yeah. So thank you guys very much. First off, to everybody here on the Automation Village, certainly want to thank those of y'all who submitted some comments to our survey question last month. Since we were looking at some of the headaches, some of the challenges you guys are experiencing. So thank y'all for those who did. Pretty common themes coming across with, data quality, trusting the data from the equipment or the software. Let's see some other comments about choosing the most important protocols. Acting on the data analytics when you get the sensor data. What's the reliability? How about obsolescence? So it's interesting, the folks who did respond, very, very common themes out there for sure. So thank you guys. So I want to welcome, many of you guys know these famous people that are here with me on the data wave. I want to welcome Lee Kibler from Riviera Utilities over in Alabama, and Ian Mertzler from Dispel out in Austin, Texas, and Pete Diffley from the Automation Village here at VTScada, but also in Charlotte. So we're just kind of waving over the interstate right now to each other. Here in Concord and Charlotte. Hey there, Pete. But anyway, for our topic today, as we prep for this, we all meet, coming into the Automation Village. So lots of discussion, lots of things every time. And how do we fine tune for this program what we're going to do? It was very interesting because I was at the South Carolina Environmental Conference last week in Myrtle Beach, mask on. And actually, Alan Hudson was there from VTScada. But we talked to a lot of the system integrators in our area that were there, from Lord & Company, MR Systems. There's several that are there, other vendors and utilities. And it was interesting talking with them about what's been going on these past 2 years, where everybody's really, really busy. Because I think everybody realized industrial, municipal, You got to have a way to see the data. You got a way to get the data. What's our obsolescence? What are we doing? So everybody out there on the street is having all these same discussions. So our side of the world, from the vendor, system integrator, engineering side, really, really busy, but trying to get product like everybody else. Then talked with a lot of our utilities that were there. Some of the same themes with workforce. Still trying to work on the workforce issues, looking at supply issues, getting things in, and then trying to figure out from an operational resilience, how do they run their business? And it's a new world we all have to live in. Then from the Hawk side, and many of the private companies that I talk to, friends at other companies, is this whole just-in-time manufacturing theme going to change? What has changed in our world of manufacturing, getting resources and providing product to customers as they're trying to do their jobs? So a lot going to be packed into this. I need to start my timer here in this now 16 minutes here with talking about operational availability. So I'm going to start with Ian. And we kind of talked about management, risk factors, workforce, part shortages, all those things. Tell me a little bit, Ian, from your perspective, maybe a problem you've seen recently in the world on this operational availability theme.
We are constantly encountering is the problem set of getting expertise for esoteric parts out to facilities in God knows where, the United States or overseas. And it relates very rapidly towards supply chain consolidation, because you have this dynamic where lots of companies are trying to onshore as quickly as possible, or at least get it within eyesight, proverbially, of their own firms. And when you do that, you need to reheat plants that haven't been running for a decade. Turns out a lot of these machines are still sitting around somewhere, but that does mean you need to get expertise there. And there are very few people that wake up in the morning and say, my career is going to be knowing how to work this 10-year-old piece of equipment, or 40 years old in one instance. So how you get those bodies on site in any normal situation is a problem, because travel time becomes a factor. So it's no longer just about responsiveness, it's also about staging and scheduling with limited resources. So the solution becomes one of either A, a training problem, or B, a problem of technology of trying to remote people in. And that's why we are exposed to it.
No, that's a really, really good point, especially in this day and age. Besides resource, is protection of that workforce and going in, and how do you stage? That's so very true. Let's see. How about Pete, from your side of the world?
Yeah, so one thing that came into my mind, I guess, overall, Pam, is that we don't always apply risk factors outside of things like cybersecurity or areas of that nature. And what I really mean, I guess, is like that the assets in any business, whether it's parts, spare parts for critical machines, sometimes isn't actually given a weighting. And I guess I kind of had a mini story. I'll try and tell it fairly quickly, where the financial side of a certain business, and this was actually for a chemical plant. And what they did was, someone had looked and said, okay, well, we'll make this rule. And the rule is that if a part isn't used, for the sake of argument, within 3 years, we'll sell it, we'll scrap it. So this happened to be a series of valves, and the valves were, priceless to the operation, really. But they were sitting there gaining dust in a warehouse. So the financial team said, okay, well, let's just ditch it, we'll scrap it. So they sold these valves for $500 in scrap. So the scrapyard took them away, all gone. And a few weeks later, there was a breakdown at the plant, and they needed these motorized valves. And guess what? They had none. So they had to go to a power plant that was nearby, and because like this plant was going to be shut down if they didn't, and they managed to actually get a spare coming back. And the idea then was that they'd buy this back for the power plant. So in my mind, it was kind of, wouldn't it be interesting if vendors, and obviously the financial teams, also have to look and work with engineering, but how about you start pooling your resources on the basis of, you put a risk factor next to things, and whether the vendor says, well, we'll carry a spare something for critical processes, that's available to a number of different entities. And now, hopefully you're not going to have the perfect storm where everyone's valve fails at the same time, but you weigh it up and you put in a risk factor. So that's kind of my thought.
Well, and it's not just availability, it's cost and downtime and all those many things when you're evaluating that risk factor for sure. Okay, Lee, I have to tell you this story, you guys. So y'all may follow us on LinkedIn when Natasha posts stuff about the Automation Village. So today on LinkedIn, Natasha sends it out. Yes, we're looking forward to it. It's awesome. Then Lee comes back and says, I had a big dose of our roundtable topic last night. So I just can't wait for Lee's to
just hope it's clean.
Oh, yes. Oh, yes. Well, obviously, one of the key metrics for operational availability is being able to document data and be able to communicate that data and make sure that you're working on your pinch points in your process. Because if your process is poor, you're not going to have operational availability. Last night I get a call 2:00 in the morning, operator can't make the headworks work. And anybody knows what a wastewater plant knows that the wastewater does not stop coming, even if you wish it to be so. So it turned out that one of the contractors had adjusted a phase monitor for 460 volts and our nominal voltage is 485. So the bandwidth of the instrument, it was running right at the edge. And our SCADA system actually told us this problem existed, and people had acknowledged the alarm but had not acted on it. So this is one of the key points of operational availability is having a way to pinch data and to know how to look at your data and to be able to interpret when your process truly is stable versus unstable. So if we would have been operating in that manner last night, I would have slept at home with my wife rather than being on stinky headworks at 2:00 in the morning. Thankfully, I was that old guy with the piece of chalk with the X. I could put the X on the machine and look at this huge panel and figure it out pretty quickly without having a environmental impact last night. So at the end, everything worked out okay. But it also shows us, hey, the importance of knowing how to document your downtime, how to have a standardized approach to how you identify anomalies, and using this action to drive change in our process. So this morning, the chief operator and I were talking about it and what happened and how we can do better. And also in the previous weeks, we've had some problems with blips in power, causing the whole plant just to shut down. And it turns out there were a lot of pieces of equipment that were not properly optimized during startup. So the equipment had a lot of capability. However, during startup, we didn't optimize these things. So it's another case of if you do not know you have a problem, how do you know how to correct it? And having the technical expertise to be able to look at the process from a user point of view and know that you didn't get the total value for what you were trying to do. So the other problem that we have is having a communication chain that pushes up in our organization so that even top management knows what's going on. Because Lee may know what's going on, but if 3 layers up in the management's team, they don't know what's going on, then in essence, nothing is happening. So the key points today for me would be documenting and accounting, having a standard procedure, and communication. Those optimize accountability.
No, I totally agree with that. And what I'm also hearing through this theme, especially with you, Lee, is training. Is you hope that all industries, all municipalities have awesome SCADA, have awesome data management, have great equipment, but it still ties back to me to people in process. And like you said, is y'all have at the Riviera, y'all got some really cool stuff, and you're trained, but sometimes you don't know what you don't know until you get into the system, and then that follow-up training, and be able to pass that information on to the new folks coming in and not have pinch points. I love the term pinch points, whether that be from an equipment side, electrical side, or a people side. You've got to look where those vulnerabilities are, that's for sure. There's no question.
For the day of a digital assistant.
There you go. Back to more of an open discussion here in these last couple of minutes for the team. We really just glazed over the things we talked about, from workforce to parts to risk to management. Just want to open it a little bit more, is how do we move forward? We all understand what hurricanes are. We all understand, unfortunately, what wildfires are, what earthquakes are. But COVID has really changed our world completely and how we're going to do business. So how do we, from today, move forward in private and public world to do better? Is it risk management? Is it training? What is that? So I'm going to ask each of you, and then kind of a group discussion. What do you think, what should be a big focus for all of us to move forward to do better? So I'll just go back to Ian, then Peter, then Lee, but let's just open it up here. So let's get a word from each of the three of you, and then let's just make this open.
Expecting that there are a bulk of other topics that come in and become factors in this. The area that I'm going to focus on, because I think it's often missed, is that these stresses that we're experiencing right now are creating a strong argument against the type of just-in-time process management that was being done before we had these series of crises. We've had a bunch of Six Sigma events, so human behavior is going to drive us all towards having huge inventories. And that's created the bullwhip effect we are all experiencing whenever we try and go and buy any equipment. That said, if we interpret this wrong, what we're going to end up doing is we're going to end up building up large inventories of product that have to be moved before we decide to innovate and create a new system. And there's a certain very well-known pump company in the US that has, the reason why they are wildly unsecure on their own is they bought thousands of chips over a decade ago, and they're still trying to move that product. So they know they want to replace it, but they haven't. So the balance point, I think, is best addressed at the supply chain level, not at the inventory level. And this is true whether you're dealing with inventories of virtual assets, as we tend to, or physical assets.
Mm-hmm. No, and that is true. What is that balance? Absolutely. Peter.
Yeah, mine is really just following on from Ian. So I would say risk management and categorizing risk that isn't just in one area, looking at more peripheral risks that maybe you it's not in your normal kind of fence. You need to start looking around it. So I think risk management across the board. I think that's really what I'd concentrate on.
So it's not just the inventory; it's what we tried a discussion too on redundancy. Do you over redundant things? Then what are you stuck with? So that Yeah. So, how much do you keep in your stable? How do you not keep in your stable? What do you make redundant? I know, Peter, just because you see a lot of different folks, what do you see folks doing there?
I think that people sometimes do what we sometimes term as it's virtual redundancy, which isn't real redundancy. So you think that you've created a redundant something, right? Whatever it may be, but you just haven't evaluated it, unfortunately, correctly. So you've got to this point of a single point of failure, and that could be a physical thing, it could be a virtual thing, it could be whatever. It could be a data center that you think, oh great, Amazon are looking after all my data needs, I don't have to worry about stuff. And then you realize that your primary and backup connections to maybe your cell network, which you're using for all your connectivity, is going to a single data center, and that isn't redundant all of a sudden. So you have redundancy between the two channels that you have with a major carrier, but you don't have it at the data center. So if that data center goes down, your redundancy may not port over to the other data center that you thought you had redundancy. So things like that happen all the time, Pam.
No, that's just interesting. Okay, Lee, how about you?
Yeah, I think the key points from an operational availability point or end user is a communication of open projects, open issues, making sure that everybody knows what's going on, and having a matrix that's available that's not just stuck in an email somewhere. The other thing is having training. Just yesterday, we had people come in and train us on how to properly adjust the clearance on a pump, on a hydrostall pump, and it was a great opportunity to prevent ragging of the pumps, which has been causing a lot of problems, and the pumps wouldn't be available, so we would have to pull the pump and go in and de-rag the pump, and it turned out the pumps were not adjusted properly, and they've been unadjusted that way for a year and a half. So it's just been a major problem. So training and communication are keys to keeping the process operationally available, and also knowing what your pinch points are, having a value, using some evaluation for operational availability, and knowing your value stream map, knowing what spare parts are going to be your pinch points, knowing what training opportunities will be your pinch point, and also your processes, which is your most unstable process, so that you can put your valuable resources in the proper location and sequence your labor properly.
Good point.
And I'll add to that, right? Be dynamic. Don't have it just a matrix or like any SOP or emergency response plan and stick it on the shelf. We've got to be nimble and update on what is happening. And I think that's a mindset change that's different for most folks, is they're used to ERPs, put it there, okay, we're done. Heck, we wrote pandemic plans, 2 decades ago. You've got to be able to pull that off the shelf and keep it dynamic, keep it to be a living document. And you're right, all up and down your food chain in your organization, so that all are aware. To me, if you make things visible, everybody's going to do better. Okay.
Yep. Amen.
Well, yeah. Any last comments before we sign off on the data wave?
Well, good.
You guys are always such a pleasure. It's wonderful. So thank you again. Yeah. Look forward to September. Yeah, always great fun and great conversations behind the scenes too. Thank you, everybody here on the Automation Village, for allowing us to be here and have fun on our roundtable. And we will hand it back over, I think, to Chris and Dave.
Hey, everybody.
Hi, guys.
Welcome to the Rocket Lander Challenge. Joining us today is Rudy Paseka from CB Automation in Ontario, Canada. How are you doing today, Rudy?
I'm not too bad. I'm not sure how we'll be in a moment, but I'm not too bad.
Yeah, so Rudy, you'll be piloting this rocket from afar. Why don't you tell us a little bit about CB Automation, and then we'll get you into your attempts.
Okay. Well, CB Automation is very happy and proud to represent Trihedral now in Ontario for the last year or so. We do automation and instrumentation products across Ontario, and I've been in the business for more than 30 years, believe it or not. You can see by my hair there. But I still like gaming, and I'm looking forward to this.
Very cool. Yeah, we're really looking forward to have you join us for this, and we appreciate you putting the time in to try this out. So whenever you're ready, feel free to launch that rocket.
And I'm safely in my basement. Okay, here we go.
That's right. So Rudy's joining us through the VTScada thin client, and this rocket application, for those who don't know, is running in VTScada. It's kind of an atypical use. So Rudy's taking off with a really nice trajectory here. He's throttled the rocket down. He's getting tipped a little aggressively, but because he's got that rocket throttled down, he might do quite well. He's really going to be skimming the top of our heads here. I think Rudy's perhaps crashing into himself. All right, see if he can get that tipped. He's got loads of fuel left. He's got definitely room for another nice little hop here. All right, this is looking really good. This is looking great, actually. So he can get the rocket twisted around, scrubbing that speed. See if he can get that nose pointed back upright. He's into the warning on fuel, but that's okay. He's still got fuel left. Reaction thrusters, I think, might be a different story. That's going to make things really difficult now.
Oh well.
That was going to be.
Well.
I think if you had a little
close.
bit more nitrogen in your reaction thrusters there, you could have got that. That was looking really good. Great attempt.
It's not the first time I've been told that. Okay, thank you, and I'll try again.
Whenever you're ready. All right, it's attempt number 2. First attempt looked great. Stresses were low. It was a nice approach. So Rudy's going for another one. These where you hover it kind of low across here can work really well. Kind of maintain control of the rocket, really have a lower probability of having this thing get out of control and just sort of blow through the ground or max through those stresses. So this is another really nice looking attempt.
Yeah. Oops, wrong. I hit the wrong button.
That's all right. There's loads of chance for recovery here. Got lots of fuel in that reaction thruster.
Come on.
Just passing through the yellow on your main engine fuel there. But he's got a few seconds left. We'll see. He's going to be right at the limit if he sticks this. Oh no!
Oh no!
Oh
no! Okay, I'm gonna go for it. Oh, I ran out of fuel. I was gonna just... Okay. Man, it does feel realistic. Okay. All right, thank you. We'll try one more time.
I think there is maybe an issue in the navigation equipment there. All right, so final attempt. The last 2 were looking really good. Getting the rocket pitched over. So he's going to carry it very low, so the air is much denser down close to the ground, but it also means the rocket's much easier to decelerate through the air, and it can be a little nicer down low, but you do burn quite a bit of fuel. All right, it's another good looking attempt. We'll see if Rudy can keep that rocket pointed up enough. He's got a big swing here. The other tricky thing about this is the center of gravity moves as you burn through the rocket fuel. Make the rocket twist quite a bit faster as you burn through that fuel because the center of pressure stays where it was.
Oh no!
Oh, so close. You got the landing legs deployed. That was so close.
Okay. That was excellent. I want to thank you very much for those.
All right, I really appreciate you joining us today, and thanks very much for those attempts. We will be talking to you in the future, I'm sure, and we'll see you guys again on our upcoming Summerfest.
Very good. Looking forward to it.
Cool. All right, thanks very much, Rudy.
Okay.
Hey, Natasha.
Hi, guys. Hey, so glad to see you in the studio together.
Yeah, I like what you've done with this frame.
Thank you very much.
So now, normally during this section, which is called Questions with Nat, you pelt us with questions related to SCADA software, and we try to answer them. This time, we just have one question for you, and that is, what is Summerfest?
Well, instead of me telling you, why don't I show you?
Well, why don't you? Wow.
So as you can tell,
that looks like a bag of laughs. What exactly is that? What could people expect who go to see that amazing looking thing?
Yeah, so that's exactly it. It's going to be an amazing online event. It's going to happen on August 31st, and people can join us and learn what has been released in version 12 so far from our CTO, Devraj. And what they can also learn is what's coming up in future releases from Glenn Wadden, our president and chief software architect. And if that's not enough to pull you in, we also have tons of chances to win great prizes. We're going to have a black tie award show that's going to have some mind-blowing entertainment. And if that's still not enough to get you to register, there also are a few surprises in the mail for those that register over the next few days. I'm going to pop a link into the chat so you can go ahead and register there. And I hope you all will join us on Summerfest.
Awesome. Thanks, Natasha.
Thanks, guys. I'll be back next month.
Awesome. So next up, we're going to have a case study from our very own Tim Donaldson in Boston.
Hi, I'm Tim Donaldson. I'm coming to you from Boston, Massachusetts today. And joining me on this case study review is Phil Arnold with Wright Pierce. Phil, I'll let you introduce yourself and talk a little bit about Wright Pierce.
Thank you very much, Tim. Wright Pierce is primarily a full-service engineering firm based out of New England. I'm actually in the Portland, Maine office. We have offices in New Hampshire, Massachusetts, out in New York, and we also have a couple offices down in Florida. Primarily, Wright Pierce does water and wastewater infrastructure engineering. Relatively recently, we also started a full-service integration group as well. So we have folks that go out and do PLC programming and SCADA development, and I'm actually part of the integration group.
What we're going to talk about today is an application that you actually built recently, and that was for the town of Exeter, New Hampshire, on their wastewater treatment facility. Could you just tell us a little bit about the wastewater treatment plant at Exeter and what some of the goals were with putting VTScada in?
This was actually a pretty unique opportunity on many parts, Tim. This treatment plant started out as a 4-lagoon plant with very little process control, with basically letting nature do the work. They actually ended up having to go to a full treatment process, of which Wright Pierce did the engineering, and we also did the integration and PLC programming, as well as the SCADA development. So the folks in Exeter went from managing some lagoons to managing a full-blown wastewater treatment plant with influent, headworks, sludge dewatering, aeration, and a UV disinfection system.
What type of PLCs and RTUs are used at this plant?
This is primarily a Allen Bradley control logic-based PLC control system. There's a couple of other PLCs out there. There's one Modicon. I believe that's it. Yeah, it's primarily Allen Bradley though.
Sure. Is it all one location where the data is coming from, or is it multiple locations throughout the town or throughout the plant?
Primarily, this is all on a local network, so it's all from the treatment plant, but they do have 9 satellite sites. So those are all remote pump stations, which we also did incorporate into this application. We're getting data from those remote sites through a Ethernet radio telemetry system.
What was some of the features of VTScada that attracted Wright Pierce to use VTScada for this project, or even Exeter to buy in on that?
One of the big features that the folks in Exeter did like was the fact that it was a one-stop shop for pretty much everything that they needed. The historian, the alarm call out, also the redundancy as well, is all built right into the software.
And you mentioned a big part of it was being able to use high performance graphics and custom widgets and so forth for that. So maybe could you tell us a little bit about that, and then maybe share your screen, and if you can show us some of that application, that'd be great.
Absolutely. So right up from the beginning, we presented the concept of this high performance graphics, which is ISA 101 high performance HMI. Essentially what high performance graphics is a way to take the data that we have in our controllers and our PLCs and our process control system and provide that in a more meaningful way to the operators, to let operators judge very quickly, is there a problem that I have to deal with, or is this system okay? Is this component okay? And really get to the root of, I need to give the attention to here, and I can ignore this over here because this is okay. And a lot of it is using visual cues, using symbology, to some extent color. And we're really not so much relying on numerical values to determine if the system is okay, but we're relying on putting those numerical values in context in relation to something else. Process ranges. What's an acceptable range? What's an alarm range? So here is our process overview screen for the entire treatment plant. Like I said, it's not a typical process overview screen. A lot of times you'll see a process flow diagram type screen that shows the entire process and some key values within that process. This screen is really more intended to show the general health of the system. And you can see we've embedded quite a few trends. Trends are very helpful in terms of judging what's going on because they show potential cycling, like we can see here. Here's a cycle. They show the history of what's happening, and you can actually use that to judge what potentially could happen in the next 10 minutes based on what's happening in the past. Without these trends in here, you would never know that this up here was happening. And that looks like a pretty wild shift, right? This is all influent flow. We had an effluent flow that went outside of the range of what we're saying is well outside of the acceptable range. So you could actually use this as a means to dive in a little bit deeper to this system and see what was going on. Another thing I was mentioning is putting this data in context. Right down here, what we have is, again, we have the numerical value, but we also have this little arrow and this gray bar that's showing the current value, but we have some other information around it showing the blue bar that's within an acceptable range. And then outside of the white bars, those are our alarm limits. So you can quickly look at this and say, hey, I'm right in the middle of the blue bar. I must be doing pretty well with that process.
That's great.
Another thing that we used is we're trying to combine several means of conveying information. And I'm going to point to these little pump icons. We have a check mark and a yellow X. Check mark means no problems here. Yellow X means, hey, there's something that's going on with this piece of equipment. We tried to make the check mark blend into the background and bring the warning conditions up to the front. So when you would be looking at this screen, maybe at a glance, you see a bunch of yellow X's, you can say, there's some problems here. I got to go and dig down what's going on. The white check blends back into the background because we don't want to bring a good condition to your attention. We want to bring the warning conditions to your attention. Another thing we are using is we're using color to convey several things. Green is running, gray is stopped, but we're also using text as another indication because some people might want to look at colors and some people might want to read a text. And so we're making it adaptable for different operators.
As well as the symbols too. So you're using symbols, correct, colors, as well as text. Yep. Nice, simple, clean design, Phil.
Thank you.
Tell us a little bit about how you created some of these custom widgets, and then show us that within the Idea Studio.
There's actually two components to this. One is building the tag database, and the other is actually developing the widgets to work with the tags that we built. And we actually heavily relied on the ability to create custom tag data types within VTScada. But the real power is we also have the ability to create those same data structures within the PLC programming. What we have been able to do is create a data structure in VTScada, create a data structure in the PLC, and then through the power of using expressions, linking through the parent-child relationship of the tag database, linking common tag names through expressions that actually directly address the PLC I/O. So for one example, we have a tag type that we call motor, and that has 81 descendants in it, 81 tags. And by linking by a single tag name by the parent, what we have is the ability to grab 81 data points with a single tag name. And what that does is obviously streamlines database development, eliminates errors because we have the template that we already know works that's going down to the PLC and grabbing the right information, makes commissioning very, very easy. Mm-hmm. So here's an example of a motor that we also have. We have other children inside of this. So we're getting all of this information in here by a simple tag name, RSLP1. As long as we have that same data structure and that same tag in the PLC, we get all this data all in one fell swoop. The other thing that we've done in here is we've added some parameters to help configure this tag so we can give it a name, and we can actually enable and disable different children in here based on whether this piece of equipment has, say, like a seal leak. This piece of equipment does not have a seal leak alarm, so we put a 0 in this parameter, and that disables all I/O associated with a seal leak. It's great for not using up your I/O tag count, because as soon as we disable this, that removes that from the tags that are used for the ones that you pay for. So we have several ways to configure this, several places to configure this, because every motor is not the same. So we get to say what is the max amps, and then this feeds back down into several parameters within the motor. So it's really truly a kind of a plug and play.
Can we take a quick look at the Idea Studio and some of those widgets that you built?
Sure. So now that we have these custom types, we also have widgets that work with these custom types. In this left-hand side, you can see the collection of widgets that we've developed. For instance, this widget right here is actually linked to one of our custom types. We call it a motor type. So everything that goes inside of this widget gets addressed at the top level of that tag. So all we have to do is say, I showed the example of RSLP1. All we do is we link this widget to RSLP1 and we get everything associated with this widget by one tag name. And actually I can show an example of that. There it is right there. RSLP1 gives you all of that information, including the actual name of the piece of equipment. So I don't even have to rename this piece of equipment. It all comes in with the tag.
From what I remember, that you started this project with version 11, and then you migrated the project up to version 12.
Yes, that migration went very, very smoothly. It was a matter of a couple of hours to update 2 redundant servers. We were actually able to maintain connectivity the entire time, at least with one server while doing the upgrade.
Let's talk about the redundancy for a second. As we know that we could physically have the primary in one building and the secondary in another building.
It's absolutely, as long as you're on the same network, you can locate them in separate buildings, and it's obvious. It is a safety factor, because if you've got an issue in one building, you're still safe on the other side.
I believe you're doing something similar to that at Exeter Water, where this is the wastewater treatment plant we've been seeing. But can you talk a little bit about how you've implemented that at the water side?
Yeah, this one's actually really, really cool, because what they have at the water site, they've got 2 independent water treatment plants that are physically separated by a distance of miles. And what we have at these sites are redundant VTScada systems local to each plant, but the plant is actually connected over the town's network. We actually have full visibility with a single application, full visibility of either plant from either plant, and they're all backing each other up. And if we sever the link between the 2 water treatment plants, each water treatment plant has visibility of its own equipment. You don't get to see what's going on at the other plant until that link comes back up. But as soon as it does, all of the historical data that both sites were collecting sync, the alarm history syncs, it all comes back together.
Well, Phil, I'd like to thank you for your time today. This has been a great insight to what's happening at Exeter.
Well, thank you very much, Tim. I appreciate the opportunity to show off some of the stuff that we've done with VTScada.
Go.
Thanks, Tim. Thanks, Phil.
Cool. And you may notice Chris and I registered for Summerfest during that moment. And according to Natasha, so have a whole bunch of you. So thank you very much for that. Chris, is that a reason to celebrate?
That is a reason to celebrate. And another reason to celebrate is that we've, remember those prizes we mentioned earlier? Well, now's the time we do that thing. So we're going to put a code on the screen.
The thing.
This. And it is the word lagoons, which featured prominently in the Exeter case study we just did. Lagoons!
Right, so that's for those of you just joining us. Send an email to natasha.lutz@trihedral.com, like you see on the screen, with the subject line, just having lagoons, exactly as you see it on screen, because it will be interpreted by a machine that needs an exact match.
So 2 lucky people who do that are going to win each a $100 gift card from an online shopping thing. So good luck, whoever you are, whoever the winners are. And lagoons is the word. So that brings us to industry news.
Ah, yes.
And this is where each of us goes out and looks at what's happening on the internet this week in the world of automation. So Natasha, tell us about what's happening in the water wastewater industry right now. What's the buzz?
Yeah, definitely. So there was a new study that came out from UC San Diego that shows COVID-19 can be detected in a single asymptomatic person through wastewater surveillance, even if that person is living or working in a multi-unit dwelling. Wow. And wastewater surveillance can detect a case up to 3 or 4 days before the individual testing can. So it's definitely a underused, cost-effective, non-invasive mass testing strategy by using wastewater surveillance. And this is a great study that shows it should be more wildly adapted.
Wow, cool. So Dave, tell us what's all the news in the power generation industry?
Yeah, so some upcoming news is it looks like Russia's going to be investing fairly heavily in these small modular reactors. So that's basically like a small nuclear power station, and they're going to be borrowing some technologies that they have from some of their Arctic icebreakers, and they're looking to implement these in places where it is very hard to run other types of power, such as up in the high Arctic, where even something like solar may not really be an option for them because of course, the low sun, but also, of course, blowing snow and ice and other things. Right. So yeah, it's cool to see them getting on board with this. We've talked about it a lot recently in North America. So yeah, stay on top of that if you're in that industry, because it seems like things are moving quite quickly.
All right, Pete, you get to scan all forms of automation except for oil and gas. What did you come up with?
Yeah, well, it was kind of a fun thing, I thought. Komatsu, the makers of all that big heavy machinery you see out there, they're going to have giant zero-emission dump trucks. So take like your Tonka truck, scale it up two stories, whatever, 2 or 3 stories tall. These things will be going around with zero emissions, probably carrying the lithium that they'll be delivering at some point. Maybe they're reusing the lithium, who knows? Maybe the battery will have run out. But anyway, the idea is Komatsu are going to do these zero-emission vehicles quite shortly, and they'll run from everything from hydrogen and fuel cells, all that kind of stuff. So watch this space.
Very cool.
Awesome. And finally, in the oil and gas industry, Crescent Point Energy released a press release last week talking about how they had partnered with QT Limited, which is an OT advisor. And basically, they had worked together to create an operational technology platform using a popular SCADA program that was able to save Crescent Point Energy, which is one of North America's largest energy producers, over $130 million in operational costs over 2 years. I know, right? With the expectation going forward that, again, another $65 million in savings year over year using what they've come up with, using operational technology, which is not usually the way you'd go about creating those kinds of savings. So make sure, and if you want to read more about that or any of these headlines that we've talked about, we will have them up on the Automation Village forum just as soon as we've had a glass of water after we finish the show. So give us about 20, 25 minutes.
Yeah, and you can check those out at forum.theautomationvillage.com.
Thank you. Awesome. So that brings us to, I think we still have more money to give away.
Yes. That's right. So we're coming up on our photo contest. So you're looking right now at an example of an impromptu workstation that was taken by Ralph, our own sort of internal photographer here. And that's of our president and Tim Donaldson, who was featured earlier.
Yeah. So basically, this is an opportunity for all of you who have to go out and install your systems in the field and need to need to MacGyver some kind of a workstation out of whatever garbage is lying around. Just take a picture, send it to us, and we've got 2 this month.
That's right. So our runner-up for this month is one by B. Nielsen.
I like this. This has got a real yard sale vibe, which I enjoy. It's really homey, really folksy. And I recognize that stool.
Yes, yes. We were saying earlier that we were looking for those stools, and now we know who to reach out to. So, right. B. Nielsen, when you finish with that, feel free to send it to the Automation Village.
And then find us another one.
Yes, and a digital copy.
Right. And next up, the other entry was this one.
Here it comes.
Boom. So this is nice. There's a lot going on here. So basically what it means is when you're done, you could just like have your partner jump in the car and take off to the next location and just keep configuring.
Yeah, I've seen a lot of offices inside the cab of the truck, fewer inside of the bed, but I like this approach.
Yeah, we've seen people working using the bed as the desk, but not this approach, which is very
right. And I heard that this chair was picked up on the way. So
Nice.
a lucky find.
Sweet. So now I guess this is the winner. So congratulations.
This is the winner. So D-smack for you.
Boom. So easy $100. So make sure again if you're out in the field and you've set up your laptop on an inflatable pool on top of a step ladder with a magazine roof on top, send a picture of that. And we're all getting punchy here at the end of the show. I think that brings us into the final. Now, this is the part we like to call parting remarks as we say things while we're parting. Natasha, what do you got for us?
I just want to remind everybody that's watching, if you haven't yet registered for Summerfest, Make sure that you do. It's going to be a great event. There's going to be so much to learn, so much fun, lots of surprises. I'll put the link to register again in the chat. So definitely register and check it out.
Great. Pete, your remarks?
Yeah, just as usual, please hit subscribe on YouTube and definitely go to our forum. We've seen a lot of people have been watching it on YouTube, but go to the forum. There's tons of stuff, and it's always being filled up with things. So have a look. Hit subscribe there.
Awesome. And what about you, Dave?
Yes, for the first time in a year and a half.
We're in the same room.
Imagine that. So what we'd like you to do is if you think you'd like to try out the Rocket Lander, then reach out to us on the forum. That's forum.theautomationvillage.com. Go to the contest section. After you post your workstation challenge, click on the Rocket Lander tab and just let us know there that you'd like to try that for your chance to win a gift card, and we'll reach out to you.
Again, lots of chances to win. And also another way you can win is if you're looking for award-winning SCADA software. It may not surprise you that this show is brought to you in part by VTScada, the world's most powerful, or the industry's most powerful SCADA software, trademark. And if you would like a version of that software for yourself, you can download VTScada Lite for free from our website, from VTScada.com. And it's not a trial, it's not a demo, it's a fully functioning version of our award-winning software for up to 50 IO.
That's right, and that's even for industrial use, not just personal use.
Yeah, right. And that brings us to the end of the show. So on behalf of all of us here in the Virtual Automation Village, we'd like to thank Phil Arnold from Wright Pierce, Rudy Paseka from CB Automation, Pam Moss from Hawk, Lee Kibler from Riviera Utilities, Ian Schmertzler from Dispel, and Sam Black from EMC.
That's right. So we'll see you guys at the Automation Village on September 23rd.
But before that, we will see you at Summerfest. Bye, everybody.